DRS really only cares about keeping your virtual machines happy. That is, can my VM get all of the CPU and memory that it's entitled to? But really, is that the only thing that goes into making decisions about where virtual machines should run? Well, it's not. It's not the only thing. I'll give you an example here. What if I have 5 virtual machines all running a web server to provide reliability, performance, and redundancy to my website? I got a load balancer in front of them. Okay, 5 VMs. If one of those VMs should fail, the load balancer kicks in, says, oh, I've got a VM that's gone down. Let's just run it on these other 4 systems. Well, what if all 5 of those VMs landed on the same ESXi host because DRS decided that that's where they belong in order to get the resources that they require? And then what if that host should fail? Uh-oh. All 5 of those VMs have gone down, the website has gone down, and the load balancer won't be able to do anything for me. So certainly there are situations where I, as the vSphere administrator, know better than DRS about where virtual machines should run. And there are a couple of different ways we can think about this. The first way that we want to think about this is by taking a group of virtual machines and deciding whether they should run on separate ESXi hosts or whether a group of virtual machines should run on the same ESXi host. Imagine I've got 2 virtual machines, one's an application and one's its database. Running that application and the database on the same host might improve networking performance in the entire infrastructure by keeping all of that traffic local to a single host. I don't have to traverse the physical network or that wire. Okay, so there are ways for me now to create 2 types of rules for virtual machines. Affinity rules that say these VMs should stay together on the same hosts, or anti-affinity rules that guarantee that these virtual machines run on separate hosts. Okay, so when I configure my DRS cluster, I can create virtual machine affinity rules. I can create virtual machine to virtual machine rules, like keeping virtual machines together or separating virtual machines. And I can create virtual machines to hosts rules that says that this group of virtual machines belongs or does not belong on this group of hosts. Let's have a look at that in the next slide here. When we want to look at virtual machines relative to the hosts that they run on. Now, why might I do this? Maybe I have a licensed dongle. Maybe I've got a couple of these little USB sticks, and those USB sticks are needed in order to run an application. Okay, I can put those USB sticks in 2 of my 32 hosts in the cluster. DRS might choose to move that VM to a host in the cluster that doesn't have access to one of these licensed dongles, and then the application should fail. So what I want to do is take this group of hosts running this application and ensure that they run on these 2 hosts. Okay, sorry, this group of virtual machines, and run it on these 2 hosts. So this allows me to first of all create DRS groups. I can create virtual machine groups, and then I can create host groups. And then I can create rules that say that these virtual machines should or should not run on this group of hosts. So this is now my virtual machine to host affinity or virtual machine to host anti-affinity rules. And there are 4 different options. They say this group of virtual machines must run on this group of hosts. This group of virtual machines should run on this group of hosts. This group of virtual machines must not run on this group of hosts. This virtual machine must not run on this group of hosts. So what's the difference between should and must? That's all about vSphere HA. Let's have a look. When I'm under normal operating conditions, if I create this group, this VM, put it in group A, I want to say that it should run on hosts in Blade Chassis A. Okay, so I create the group, I put the one VM in the group, I create the host group, I put the 2 hosts in that group. Now what happens if those hosts should fail? By creating a should rule or a soft or preferential rule, then HA will be allowed to power on that VM on one of the other hosts in the cluster. Okay, so this is all about HA. When the other hosts fail, VMs will be allowed to go somewhere that violates the rule. When the hosts power on, DRS will migrate the virtual machines back onto the more appropriate hosts. But a required rule, for example, that I would create when I have those dongles, says if the hosts with the 2 dongles on it fail, well, then the application's not going to run anyway. So simply don't power on the hosts. Don't power on the VMs. Okay? You'll lose them. The VMs will go down. When the hosts come back up, the VMs will power on the hosts that are more appropriate for it, that have those licensed dongles. So that is a required rule for VM hosts. Now let's finish this little bit of configuration around DRS by looking at virtual machine level automation. In the Configure tab of a cluster, you can select virtual machine overrides. And what this allows us to do is violate or go outside of the rules, the general rules that I have set for the cluster itself. And when it comes to DRS, this allows me to take an individual VM and select disabled. Don't ever think about moving this VM. Okay? Manual, maybe allow me to select whether or not I want to follow your recommendation if you want to move the VM. Partially automated or fully automated. So it allows you to override the settings that you've created on the cluster. Requirements for the cluster say that ESXi hosts have to meet these certain requirements. Okay? If I want to use DRS for load balancing, then we have to meet vMotion requirements. And you know all about the vMotion requirements. If you can't meet vMotion requirements, we can still do initial placement. Okay? Of course, we want to be able to do vMotion. So if you can make homogeneous clusters, all of the hosts in the cluster have similar hardware or identical hardware, right? And they all have shared storage, then you'll be far better off when you run DRS. Finally, we can have a look at resource utilization in our DRS cluster. We can go to Monitor and then look at CPU, memory, and network utilization. And we can see that the ESXi hosts will actually show you one little block for each virtual machine. And it shows you a color map or a heat map to tell you whether each of the VMs across the host are getting the resources to which they're entitled. Okay? If the host is under contention, like it appears that this particular host is getting close, then the VMs are not performing as well as they could be if perhaps they were migrated over to ESXi 02. So maybe DRS might choose to migrate this at the next 60-second interval. Or perhaps I have a partially automated or manually automated cluster, and I might have some recommendations, which you can see on the left-hand side there, that say, hey, let's move this virtual machine that's in the yellow down to ESXi 02 in order to achieve better performance. Speaking of recommendations, when I have a cluster in manual or partially automated mode, DRS may have some recommendations. It may want to migrate some VMs, but it's going to wait for us to approve those recommendations. So you can see recommendations over here. I've got a couple of priority 2 recommendations. Remember on that scale of 1 to 5, 1 being the most conservative and 5 being the most aggressive, I have a priority 2 recommendation that says migrate these 2 virtual machines, Photon 11 and Win10.04, from ESXi 01 to ESXi 02 in order to balance CPU loads. Okay? Do I want to do that? Well, select the ones that you want to do and select Apply Recommendations. If you don't want to do them all, hit that little Override DRS Recommendations button, which will allow you to select the recommendations that you would like and deselect the recommendations that you do not want to follow. Then you hit the Apply Recommendations link down in the bottom right. Now, don't forget about maintenance mode. And this also applies for standby mode on an ESXi host. If you place a host in maintenance mode in order to patch it or remove the host from the cluster, don't forget that this actually pulls resources from the cluster. I know it should go without saying, but I'm going to say it anyway, right? It makes sense. If the DRS is down a host, it doesn't have those CPU and memory resources anymore. So it might create an imbalance in the cluster or contention in the cluster as DRS in fully automated mode, when you place the host in maintenance mode, will migrate the virtual machines to other hosts in the cluster. Okay? In order to enter maintenance mode, all VMs must be either powered off, suspended, or moved to other hosts in the cluster. Okay? In fully automated mode, DRS does this automatically. In partially automated or manual mode, you try to enter maintenance mode on a host, the host says, I'm sorry, there are VMs running on here. I can't go into maintenance mode at this point. It then relies on you to do manual vMotions in that case. Okay? If you place a host in placing a host in maintenance mode is something that a DRS cluster might do if you've enabled a feature called distributed power management, which really kind of does the opposite of DRS, which says, hey, the load isn't heavy right now. The load is really light. And I've got 32 hosts in this cluster or 64 hosts in this cluster. And theoretically, I could run all of these VMs on half that. Let's actually migrate the VMs together and send the other hosts into standby mode, conserving some power. Well, that's really a cool thing to do if you care about saving power in your data center. And we all should, of course. Okay? So distributed power management will take those hosts, migrate them together, evacuating some hosts that will then send into standby mode. When the load comes back and increases, DPM, or distributed power management, will identify hosts and fire them up, take them out of standby mode. It'll do a wake on LAN type or IPMI power on, and then migrate the virtual machines back using DRS. A very, very nice feature. If you want to remove a host from any cluster, that host must be placed in maintenance mode. Okay? You can then power off the host. You can drag the host into a different cluster. You can pull it out of your data center, whatever you like to do. Okay? So before you shut down any host, put it in maintenance mode. Before you try to take it out of a cluster, it must be in maintenance mode. Before you try to patch an ESXi host, it must be in maintenance mode. We'll talk about patching hosts in the Lifecycle Manager module coming up next. When we come back, we're going to have a brief look at a feature called Dynamic Direct Path I/O, a new feature that was added to DRS in vSphere 7.